Hello everyone, a warm welcome to viewers of my presentation. First of all, let me introduce myself. My name is Manamita. I am studying 9th grade from TSWIS Girls Patenting from Medicus TG. Okay friends, I am asking a few interesting questions on my topic. If you know the answers, please comment down the answers in the comment box. Okay, let's start our class. Okay, first question. Human beings have how many permanent teeth? 32 permanent teeth. Or they same or different types of teeth. Okay, how many types of teeth we have? 4 types of teeth. Incisors, canis, premolars, and the molars. Okay, it is an open mouth teeth teeth. Okay, the teeth will be divided into 4 parts. One part and second part and the third part and fourth part. The teeth will be divided into 4 parts again quadrants. Okay friends, do you know what is the dental formula? Okay, we can write a human dental formula as 2, 1, 2, 3. Means it tells us 2 incisors, 1 canis, 2 premolars and 3 molars. Okay, now we have to find out the number of teeth with using the dental formula. Okay, now we know what is the dental formula. Dental formula is 2, 1, 2, 3. We have to multiply 2, 1, 2, 3 into 4 because the teeth will divide into 4 parts. Means we have to multiply 4 into 2, 1, 2, 3. 4 2 is 8, 4 1 is 4, and again 4 2 is 8, and 4 3 is 12. Here 8, 4, and 12. When we add these 8, 8 16 plus 4 20, 20 plus 12 32. Here we get 32. Means here we are using a common property to classify the whole teeth will divided into 4 parts. Here it is a collection of teeth. Okay friends, it is a collection of teeth. Nothing but a set of teeth. Okay friends, are you getting any idea of our topic? Yes, in this presentation we are discussing about set theory and its uses. Okay, learning outcomes. Student, in this session, we are going to learn about sets theory and its uses, and Venn diagrams, representation of diagrams, and basic operations of set theory, and these concepts, where we can use these concepts in our day-to-day life situation. Okay, next. Okay, friends. Okay, now we discuss about a set theory. Okay, set theory was developed by a famous mathematician. He is known as a George Conter. George Conter was known as the father of the set theory. Set theory covers the basic of topology, the study of sets together with the properties of a various collections of a subset. Here you can see in the slide, we have a picture of a George Conter. He is known as the father of a set theory. He was developed the set theory in 1873. He belongs to a German country, and he given a statement that set is a form of a possible thoughts. The George Conter was given a statement. Okay, next we discuss about the cardinal number. The number of elements in a set is known as a cardinal number. Okay. Example, set A is equal to 1. In set A is equal to we have 1, 2, and 4. In set A contain 1 to 4. Here, what is the cardinality and What is the cardinality on here? Means we have three elements on it. We have three elements. It means we have it is a we have a three. We have a three. Means it what's the cardinality on here? Three. A set A represents the number of elements in a set is equal to 1, 2, 3. Next roster form. In this roster form, the all elements are written in a curly brackets and separated by a comma. Okay, here we can take one example. Okay, the natural numbers less than the 5 means the natural numbers are starts from 1. Here they are asking less than the 5 means 1, 2, 3 and 4. Okay, now we have to write in a set. Set A is equal to bracket 1, 2, 3, 4 and the close bracket. Okay, it tells us a roster form. Next, a set builder form. In order to write or represent the elements or rational numbers less than 10, maybe it is easy. In the same way, we have to write the natural numbers less than 100 or 1,000 or 10,000. Maybe it is a large process in the roster form. Yes or no, isn't it? It's a long process in a roster form. That's why they are suggested to use a set builder form or a ruled form. Okay, in this ruled form, we can write a set in a single statement. Okay, here we have an example. Set A is equal to x such that x is a natural number less than 5. Means A is a set name and x is a elements and x is a natural number. That is a condition. Okay, that is a condition. Okay, what is a set? Set is a well-defined collection of a distinct objects or elements in its same type is called as a set. Okay, here it is about set. Next, we discuss about types of sets. Next, we are discuss about the types of sets. First set, union of sets. Next, we discuss about types of set, empty set. Okay, in empty set does not contain any elements in that set is known as an empty set. Okay, maybe next slide. Can you show that? Okay, we can consider as it is a set K. So we can consider as it is a set K. In this bowl, I have to consider the set K. If you see any elements in that set, no. We can consider as a set K. You can see any elements in the set? No, because it says a empty set. Okay, empty sets are denoted by a pipe or a curly bracket. Next, singleton set. Singleton set means it contains only one element or a single element in a set is called as a singleton set. Okay, now we have to take one example. We have to do one activity on it. Okay, let us consider as this formula as set A. You can consider the set A. And here I'm putting one object on here. You can observe here I'm putting one object on here. Here you can see we can see how many objects and how many elements on this set A. Only one element means it tells us a singleton set. Okay. Okay. We have in the slide we have the set of all natural numbers less than 2. Means here the natural number starts from 1. Here they are asking the natural numbers less than 2 means set K is equal to a 1. Here you can see in a the Lord Ganesh image. Okay, we have how many images on single image we have? Single image of a Lord Ganesh. It is an example of a single set. Next, finite set. The number of elements in a set is called as a finite set. Means you have to count countable the elements in a set. So let us take let us do an activity on it. Okay, let us consider it is classified as a set K. And let us consider these are the elements. What are these? These are the piece of stuff. You can consider as a set A. I am putting now these elements in a set A. Means now you have to start counting. 1, 2, 3, 4, 5, 6. In set A contain 6 elements. Means here you can observe we are able to counting the numbers in a we are able to counting the numbers in a finite set. Okay, in slide we have a set of English alphabets. A set of English alphabets. The English alphabets are 26 letters. Means we are able to counting as a B, C, and etc. like X, Y, Z. Okay, it is an example of finite set. It's infinity set. It's a bright opposite of a finite set. Means we are unable to count the number of elements in that set. We can't be listed. That's it. Okay, here we have an example. The set of all natural numbers. The set of all natural numbers. Okay, we can say the natural number starts from 1. Then we can say there is end of a natural number. No, we can't say there is no end of a natural number. We have infinity numbers. We can see here we are representing the natural numbers in a number line. You can see here. It's the representation of a natural numbers. It is a representation of a natural numbers. Here you can see 1, 2, 3, 4, 5, and the comma, etc. etc. We have infinity numbers. We have an infinity. We are unable to count the natural numbers. Okay, next here you can go in a slide. We have a set of all points in a plane. Okay, here you can see in a slide. We have a plane figure. Means we are able to count in the how many points in a plane. No, it's impossible. We have uncountable points are there in the slide. The next equal sets. Next equal sets. The two sets are said to be equal if they have exactly same elements. Okay, let us do one activity. Then you understand what is an equal set. Okay. Let us consider is a set A and the set B. Okay, here in set A contain some elements, some powers. We have to say some powers. It contain a equal. You have a equal elements. In set A, you have an equal elements, and set B. In set B, also have equal elements. When the A and the B have equal elements, then we can say is a equal set. Okay, you can observe in this slide we are inserting a different types of sets. Okay, here we have a triangle. You can observe that. Then you understand easily what is the equal set. Next, the universal set. Universal set is the superset of all sets. It is the superset of all sets. It contains all objects, elements on it. And it contains all objects, elements. It is every set is the superset. Every set is the subset of superset. Okay, we can here we have an example. The set of real numbers. Okay, we can consider here real numbers are a universal set. What are the subsets here? Natural numbers, whole numbers. Here we can consider it is a real numbers. What are the subset? Natural numbers, real numbers, whole numbers, integers, and the rational and the irrational. These are the subsets of the real numbers. Okay, this is about the universal sets. Next, union of sets. A union of sets of two or more sets is a set of all those elements which are either individual, both, or a common. Okay, let us do one activity on it. Okay, let us do one activity on it. Let us consider as this power as a set A. Okay, I am putting three circles, three different circles. Three different circles on set A. And we can consider it as a set A, set B. And I am putting the different types of circles in set B. Means union means we have to form A union B. We have to take the numbers from A, B, then we form A union B. Means what are the elements in A? What are the elements in A? Three elements: silver color, the silver color, and the black color. Then I am putting on here. Okay. Let us take the elements of set B. Three elements. Putting on here. Here, these are, we have to consider this part as A union B. Means here we are forming now A union B. Okay, we have to take elements from A and B, then we have to form A union B. It is a simple way you can see. Next, intersection of a set. Next, intersection of a set means the intersection of two sets of those elements which belongs to the intersection of two sets. Those elements belongs to set A and set B. Okay, here in the slide we have an example. Set A. Okay, in set A, 1, 3, 5, 6. And set B, 2, 3, 4, 5, 6, 7. And close by. What are the common elements on set A and set B? We have to take a common element in set A and set B. Then you have to form a intersection B. What are the common elements on here? Okay, let us do one activity on it, then you understand very well. So let us consider it is as a set A, and I am putting three different colors of on set A, and I am taking three different on set B. Okay, here it is a set A and set B. What are the common here? You can have the clearly. What are the common circles are here? Yes, it is a blue side. Blue is a common element. Okay, blue is a common element in set A and set B. Set A and set B means we are forming A intersection B. Okay, we have to consider the set A this, and we have to form 2. Which we are forming A intersection B. Okay, next subset. Okay, every element of a first set is also an element of a second set. Then the first set said to be a subset of second set. But let us do in slide we have a set A contain 2, 4, 5 and B contain 1, 2, 3, 4, 5, 6, 7. Here you can observe 2, 4, 6 are there in B. Means A is the subset of B. Okay, A is the subset of B. Okay, next disjoint set. Disjoint set, a consider A and B are two finite sets and there is no common elements on it. Disjoint means the different elements. How to take different elements on it. Okay. Here we have an example. Set A contains 1, 3, 5 and the B contains 2, 4, 5. You can observe here. You can find any common on there. No, we can't find a common element on there. Okay, it is about disjoint set. Next, differences of set. The differences of set A and B is a set of A and B are a set of elements which belongs to A but not belongs to B. Okay. So let us in the slide we have in set A contain 1 apple, orange, and the banana, and the grapes, and the mango. And the B contain apple and apple, orange, and the banana. Okay, now we have to do A minus B. Means we have to minus from A. We have to minus from A to B. What is the common elements on here? A get cancelled, and the orange get cancelled. Banana get cancelled. Then what are the remaining elements in set A? Grapes and the mango. These are the remaining elements in set. Means what is the A minus A? A minus B? 2 elements. Grapes and mango. So let us take one more example. In set A contain lily flower, rose flower, and sunflower. In set B contain hibiscus, rose, and the sunflower. Okay, now we have to do B minus A. We have to cancel from B to A. Okay, then rose get cancelled, sunflower get cancelled. What are the remaining elements in set B? Means we are doing a subtraction from B. So we have to consider we have to write element in from set B. So what are they here? Hibiscus is A minus B. Example. You can see in the slide we have an image. How to observe then what is that? B minus A is equal to a hibiscus flower. Next we discuss the fundamental things on a set. In this now only we discuss A. What is the A union B? What is the intersection B? Okay, now only we discuss about A union B and the A intersection B. Means in this fundamental theories only we have same in fundamental theories we have the same concept. means how to theories means how to write a set. How it tells us. Okay, now we have fundamental theories. Okay, fundamental theories on a set. Number of A. Okay, let us take set A is equal to 1, 2, 3. Means what is the number of A? 3. We have to see coordinality on here. Okay, what is the coordinality on set A? Means here I am saying means I am saying I'm taking my own numbers and then I explain to you. Okay, you can notice that. Okay, set A. Okay, first one, the number of elements in the set A means you have to take a number set A contain 1, 2, 3. Okay, what is the coordinality? What is the n of A? 3. In the same way, we have to take 3, 4, 5. So what is the coordinality on B? 3. Okay. Then if these are the same examples of that. If A and B are the two disjoint sets, then the A union B is equal to number of A plus number of B. Okay, it is an example. Okay, these are the theorems. Okay, next third one. The number of A union B is equal to number of A plus number of B minus number of A intersection B. Next, fourth one. The number of A union B, then the number of elements in a set, the number of A union B is called as the cardinal number of A union B. Means we are discussing the A union B intersection B in the class. Means how it is can take as a consider as its work, and you have to apply those numbers in it, and you have to comment on a common box. Are you clear about it? Okay, I think are clear about this. Next, Venn diagrams. So Venn diagrams was introduced by a famous mathematician. He is George Venn. So that's why the diagrams are known as a Venn diagram. Okay, here we have one flip cards like that, like this. Okay, first we discuss A union B. Okay, I'm taking example like this. I'm taking one example. In set A contain 1, 2, 3, and set B contain 4, 5, 6. Then how to write A union B? How to mix? How to take from set A, set B, then we have to mix A union B. That's why we have shaded a total area of it. You can observe here. We have to shade a total area. Means we have to take the elements from A and B. That's why we are shaded a total area. I think I understand about this. Next, A intersection B. Okay, intersection means we can simply we can say means intersection means you have to consider as a common elements. What are the common elements in set A, set B? How to think. So in a simple way, can say A and B is have to fill the total. In A intersection B, you have to fill in a middle part, intersection part. Okay, intersection. But later we are doing one activity on in types of sets. Okay, now we are intersecting circles like this. Okay, I think are clear about it. Okay. Next, differences of sets. The differences of sets means A minus B means have to we have to cancel. Now we are doing an activity on it. We have cancelled the apples and A contain mango and grapes. What? Okay, we have to cancel from B from A. That's why we are flipping A and B from A. Means B from A here we are doing one activity on it. What are the remaining hibiscus the remaining? Okay, and means Venn diagrams are showing a representation of shading on circles. Okay, it is that's why we are filling shaded B part. Okay, mean A dash means we can call as A dash. We have 3 different names. A dash means a complement or A prime or A dash. We have 3 names of and we have to get 4. A dash also 4. We have 4. A dash means simply we have to fill up except here you have to fill up total area. You can see in the slide A dash because they are filling except here they are filling. Okay, A intersection B. A intersection B dash means you can say we have to not fill up B. First you have to observe where first you have to observe where is a dash. Here you can see in the question we have a dash on B. That's why we have to fill up that part. You have to fill up except that means we have to fill up A part. Okay, are you clarity on it? Then next A dash union B. Okay, it is a reciprocal operator. Means we are filling except A from B. Okay, like that we have a different types of Venn diagrams. Then next we discuss uses of set theory. Set theory is assist the planning or operations. Okay, we can use these set theory concepts in kitchen, school bags, shopping malls, and the universe and the medical stores, library, and etc. Oh, we can use the set theory in many places. In departmental store also we are using. Means they are arranged in a group of in a systematic order. Okay, it is about the set theory and its uses. Next. Okay, last but not least, okay, now we discuss summarize. Means what we discuss in this session. In this session, we are discussing about set theory and its uses. Yeah. What are set theory? Set theory, cardinal number, rule method, roster form, types of sets, and Venn diagrams, uses of set theory. Okay, we are discussing different types of content in this session. I hope you all enjoyed my class. Okay, let us conclude that. We are discussing Venn diagrams in this session also. Means set is it is an easy chapter, and all our thinking is maths is a very hard subject. Means when we are doing like these different activities, then we have to observe very easily. They don't think maths is a very hard subject, and it is a playway method. Set is a playway method. Means you have to understand how to grasp it easily on sets. This set is a very useful and very small topic. Okay. So let us conclude that. Let us have any questions.
Okay. Thank you, Manohita. Can you hear me? Manohita, can you hear me?
Yes, ma'am. Yes, ma'am.
Okay. So, Manohita, can you explain us one of the examples that you have given already in detail, where you were giving an example of in the uses of set theory? You said the set theory can also be used in the kitchen. So, how it can be used in the kitchen? Can you please explain us more about it?
Okay, madam. Thank you for question, madam. It's a really very good question. The kitchen is the most relevant example of a set. So my mother always keeps the kitchen in an order, in an arrangement, in a systematic manner. Then I will take, oh, here we have a plate, set of plates. Here we have some ingredients. So here we have an ingredient, means cups. Means there here sets is a means here kitchen shows how where the items in easy way. You have to catch up in easy way. Then you have to prepare recipes or in it. It is a kitchen sets are similarly utensils keep separately. Kitchen is the most relevant example of a sets, madam. We can in kitchen we can say we have a arrangement in a systematic model. We have plates and you have to do, in this form we are not wasting the time. So, we are not wasting the time. Then we have to finish what is the work on it. We have to finish in easy way.
Okay. Thank you. And also, did you find did you find about the traditional set theory, and what do we call the traditional set theory and why? Can you see any difference between the traditional set theory and the developed set theory?
Okay, madam, thank you for your question. It's really very good one. Traditional set theory. Membership fixed exact either the members in a it's a false or a not. There are two crisp values. There is a false and a true in a traditional set theory. Now we are using a fossil logic set theory. Now in the modern generation, we are using a fossil logic set theory. Extension of fossil logic set theory means extension of a traditional set theory. In case the fossil logic there, the many values, weights, say the x, the member of is in a set. It is having a variable. Means in this traditional generation we are using a membership. We have to use in a two. We have to using two values, or a false or a true. Now the modern generation we are using a lot of fossil logics.
Okay. Thank you, Manavita. We are done.
Okay, ma'am. Thank you, ma'am. First of all, I am very thankful to R.S. Praveen Sir garu. R.S. Praveen Sir garu. I'm thankful to R.S. Praveen Sir garu and my principal madam and my mentor teacher and my parents and who have supported me a lot. I'm very thankful to the bottom of my heart. Thank you for giving this opportunity. Thank you. Stay home, stay safe. Jai Hind.